Today we multiply and divide rational expressions. Let's do it, and let's do it now. Mercado math, it's time to do some math. Let's Merca do it. So this is a rational expression. This piece right here. Rational expressions, the easiest way to describe them are ugly fractions. They follow all the same rules as fractions. Everything you can do with a fraction, you can do with a rational expression. You can multiply them. You can divide them. You can add them. You can subtract them. And if you think about what the word rational expression means, rational is a number that can be written as a fraction, and expression is all the crap with x's and y's. So there you go. It's an ugly fraction with x's and y's. Now we play the game. So just like a multiplication problem, if you had fractions, you can multiply right across. That's the easiest way to kind of do this. So we're going to multiply straight across. 4 times 5 is 20. X to the 5th times x to the 4th is x to the 9th. Y to the 3rd times y to the 5th. Y to the 8th. Multiplication, we can multiply right across the numerator, and we're going to do the same with the denominator. 9 times 6, 54. X to the 3rd times x to the 9th. X to the 12th. Y squared times y is y to the 3rd. Once we multiply, we have to look to see, can we simplify anything? And we're going to look and realize regular numbers are regular numbers. You simplify those the way you always had. 20 over 54, you reduce. What goes into 20 and 54? We just reduce it by 2. And we get a 10 over 27. X to the 9th over x to the 12th. If you remember the power rules, this is the quotient property, but you have more on the bottom. There's 12 on the bottom, 9 on top, so you know your x's are going to be on the bottom. How many more do you have down there? 3. It's subtraction, but you know the direction of where to go. So 12 minus 9 is 3, but you know they're going to be on the bottom. That's where there's more of them. Y's, you got 8 up top, 3 on the bottom. Where do you have more y's? Up top. How many more do you have up there? 5. And there's your answer. Okay? It's basically a harder version of what you were doing in Chapter 7 with the power rules. When you look at it, there's another way you could have done it. I think it's safest to multiply first and then simplify, but some people could simplify here. I could have reduced 4 and 6 here, 2 and 3. 2 times 5 would have given you the 10. 9 times 3 would have given you the 27. I could have tried to simplify all these x's and y's ahead of time. I think that's more chance for a mistake, but it's not wrong. You could do it. There's a lot of different ways to do this stuff. This is just one way, and the way that I think is the easiest for. So now we're going to jump into this problem. This would be considered a hard multiplication problem if it has a little bit of everything in it, so that's what's good about it. So if you can do this multiplication problem, you can pretty much do them all. So, once again, rational expressions. Rational means it can be written as a fraction, and these are expressions. If you remember what an expression is, it's an equation without the equal sign, and those are expressions. Here's a fraction made up of expressions. In math, they're not very creative with their names. It is literally what the name is. So first thing we're going to do, we're going to look at the numerator. Numerator, 4x to the 5th. Can't do crap with it. It just stays that way. This denominator I look at, and this should look very familiar because we're going to be factoring. We're going to be factoring 3 times in this problem, and we're going to be using 3 different methods. So hop aboard that factor tractor and let's farm. 20. Things that multiply to give you 20. This is basic factor. Things that give you 20 are 1 times 20, 2 times 10, 4 times 5. You need the numbers that also add up to 9. That's 4 and 5. This factors to x plus 4, x plus 5. This numerator. This should be your favorite one. If you forgot it, you'll remember it very quickly. It's the difference of squares. And if you remember, the difference of squares factors to conjugates. X squared minus 16 factors to x plus 4, x minus 4. Difference of squares. Some of you that are a little brighter might be noticing something already and might already know what's going to happen. If you haven't noticed, it's not the end of the world. That's what I'm here for. I'll show you and you're like, oh crap, yeah, that makes sense. Down here, this was the first type of factoring we learned. This is GCF, factoring using GCF. 10x squared minus 40x. 10 and 40 have a GCF of 10, so I take out a 10. X squared and x, I could take out an x. And then once you factor that out, what's left is an x minus 4. Once you're here, some of you that are a little neater, like for me, I would go from here to get the answer. I'm going to rewrite it now. Once again, this is one of those steps that if you're neat, you don't really have to do. If you're a little sloppy, you probably want to take this step and do it. So my numerator, everything I have in my numerator, I got a 4x to the 5th. I have an x plus 4. And I have an x minus 4. My denominator, I'm going to put that 10x up front, but I'll still write all this. So I have an x plus 4. I have an x plus 5. This 10x, I'm going to put it in the front because, you know, coefficients usually go in the front. And that's kind of this, I always like to just call it the loose crap. All these kind of loose things you just put in the front. And this x minus 4 is also part of the denominator. And now that you rewrite it, hopefully it becomes a lot more obvious. Some of you might have noticed it when I was writing it here. At this point, you really do have to see it. And what you see is this x plus 4 cancels out. These x minus 4s cancel out. And the part that everyone always kind of screws up is the part that you've done before. This is the stuff you did in chapter 7. You have to simplify all this regular crap. 4 and 10 are just two regular numbers. It's a regular fraction. You got to reduce it. 4 and 10 reduce to 2 over 5. The x to the 5th and x, these are just some random x's. These are loose x's. You have to simplify those. 5 up top, 1 on the bottom. Where do you have more at the top? How many more up there? 4. So that 4x to the 5th over 10x simplified to 2x to the 4th over 5. And then you look, what else you have? Oh, I got this x plus 5 still hanging around in the denominator. So x plus 5. This is my final answer. 2x to the 4th over 5 times x plus 5. Now, once again, I rewrote this. I'm taking my time, being neat about it. In reality, like I said, I think a lot of you can go from here to here. If you pay attention, these would have canceled out. These would have canceled out. And you have to look and reduce for these. So like I said, I think it's okay to do it either way. This is the way, like I said, that really you should kind of see it. But once you understand it, I think a lot of you can kind of just skip to this part and just, you know, do it a little faster. Save a few seconds. Why not? What else are you going to do? This isn't the 5th floor. Oh, hey guys. We're going to divide now. So division, if you remember how division works with fractions, it's kind of the same as multiplying, but with a twist. Literally. It's that whole keep, change crap, or keep, change, flip, or keep, flip, change. I don't know what the hell you guys learned. I learned multiply by the reciprocal. But whatever way you remember it, it's that. So the first step of this, I strongly recommend rewriting it. I can't tell you how many people think, oh, I'll just flip it later. They factor, they solve it, and they forget to flip it. Because when you're doing all this work, you forget those little things. So I'm going to literally waste a lot of time here, but it's a very important step. And I'm just going to rewrite this with this flipped. Keep this first rational expression. X squared minus 81. Change division to multiplication. And flip this sucker. So that becomes a 12x over 3x squared plus 6x. Now, it's the same thing we were doing in the last problem. Almost exactly the same. If you really know what's going on, I gave you 3 things to factor again. You're not always going to have to factor 3 times. I'm doing that so you kind of see the practice again. So I'm giving you, there's another basic factor, another GCF, and another difference of squares here, just so you get that rhythm again of factoring. Because if you got some of you getting very good at factoring, and then all this happens. So I mean, it sucks, but if you're good at factoring, this stuff is really easy. So let's factor. This is where a bigger board would really come in handy, you know? I want to erase this. I don't think I'm going to. But I'm going to write the blue up here. This is basic factor. And this is the type that you guys screwed up a lot because of this negative. We need numbers that multiply to give us a negative 18 and add up to give us a negative 7x. So if you remember, negative numbers happen with a positive and a negative. Negative 18, 118, 29, 36. Not a lot of choices there. So you should kind of be eyeballing that 29. And hopefully, whether you have to guess and check or you just know, because of that negative 7, the dominant sign goes with the larger number. So when you have that 2 and 7, the bigger, the 2 and 9. The 9 will be the negative, and the 2 will be positive. Remember, when you add or subtract with different signs, you keep the dominant sign. You subtract, keep the dominant sign. Difference of squares. How do I know it's the difference of squares? It's the difference of two squares. Once again, not very original with their naming process. This factors to an x plus 9, x minus 9, because the square root of 81 is 9. 9 squared is 81. Difference of squares. 12x. It's just 12x. 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 GCF. This is actually the factoring, even though you did it first, that people have the most trouble with still. Basic factor isn't so bad. Difference of squares goes real quick if you notice it. This is still kind of the big issue for a lot of people by this point of the year. 3 and 6. The GCF of 3 and 6 is 3. X squared and x, they both have an x in common, so I'm going to take out an x. And then what's left behind? An x plus 2. Now I'm very tight on space here. I did not plan this out well at all. Poor decision making on my end. Not the first time and not the last. So I'm going to go save a little time and cross things out here. I got an x minus 9, x minus 9. Cross those out. Hey, an x plus 2, x plus 2. Get the hell out of here. And then I have this loose crap, the 12x over 3x. So let's write down what we have now. Hopefully a lot of you already know what's going to happen here. In the numerator, that's all gone. This whole numerator's gone already. I have a 12x. Denominator, I have an x plus 9. And there's a 3x still hanging around. This is my loose stuff, the 12x and 3x. You still have to simplify that. So kind of pretend that x plus 9 isn't there. These x's will cancel, and 12 over 3 is just 4. So this whole thing simplifies to a 4 over x plus 9. And because the x plus 9 is by itself, you really wouldn't see the parentheses. It's not wrong to have the parentheses, but in reality, you would never see them. The parentheses are there when you got other crap going on. That 3x, you got to separate it. And that's my pretty basic answer. We're going to do one more. It's going to be very similar. I think a lot of you would have mastered it. It's just for this one, it's a mild mistake that does occasionally occur. It doesn't happen that often. Most of you, I think, will not make it, but I'd stay to watch it just in case. All right, now let's get back to the floor basement. Alright, so for this one, it looks kind of like the last one. There's division, there's rational expression, but that's just an expression. The very simple way to explain this and not really beat around the bush, put this over 1. That'll save us the hassle. Because now when you keep change flip, you realize when you flip this, it's actually going to be 1 over x squared minus 4x minus 12. What happens is some people forget to put the 1 there, and when they flip it, they think it just stays the same. Putting it over 1 kind of just gives you that visual of it actually moving. And now it's the same crap. We're really going to work on some basic factoring in GCF. So I'm going to try to kind of skip the chase here. 24. Things that give me 24. Let's do it the old-fashioned way. Let's write them all. Oh, I don't want to write them all. There's 1, 24, 2, 12, 3, 8, 4, 6. You want something that adds up to negative 10. So you kind of look at that 2, 12, and 4, 6. However, you look at your signs. To get a positive, it's positive, positive, or negative, negative. Negative 10 means negative, negative. So that factors to an x minus 4, x minus 6. Denominator, remember we're keeping this, so I'm just factoring it, saving a little bit of time. This is GCF. GCF always has that kind of could be anything look. Basic factor always has that x squared and it's a trinomial. Difference of squares is always a binomial and is a difference of two squares. And GCF can look like anything, so when it looks weird, it's probably GCF. 12, oh crap, I screwed this up. That was supposed to be a 24. Let's just fix that. And now 12x to the third plus 24x squared. 12 and 24, I could factor out a 12. X to the third, x to the second, I could take out two x's from both of them. And then what would be left behind, if you remember how it works, you are kind of dividing that 12x squared out. You'll be left with an x plus 2. Keep, change, flip. So this is flipping. So I'm going to put a 1 up top. And now I'm going to factor this x squared minus 4x minus 12. Negative 12, how do you get a negative? A positive and a negative. So I know one's going to be positive, one's going to be negative. Then it's a matter of playing with the numbers. 12, 1, 12, 2, 6, 3, 4. I'm looking at that 2, 6. The negative is there. That means the negative is the dominant number. So 6 wins that fight. Negative 6 times 2, negative 12, negative 6 plus 2, negative 4. Hoo-ha, dilly. And now once you're here, start canceling crap out. X minus 6, x minus 6, and that's it. Nothing else cancels out. Don't be that person who tries canceling these out. They are the same. However, you can go from top to bottom, numerator, denominator. I cannot cancel these out. There's nothing else for me to do. My final answer, it's going to be one of our uglier looking ones, but it does actually happen pretty regularly, these ugly answers. It's going to be an x minus 4. Let's use a different color for my answer. Let's go black. X minus 4 over, what's left in the denominator, a 12x squared. There's nothing for that. There's no other loose stuff. So that 12x squared is just going to stay that. Then I have an x plus 2, x plus 2. Now you might see it left like this, and I would give you full credit for that. In fact, I think a lot of people would write it like this, but it's also very possible you might see it like this. I can't tell you which way you would see it on SATs, on anything like that, college entrance exams. I can't tell you how you would see it. Just be aware that both of them mean the same thing. All right? Now, onto our puns. All right, now onto our puns. See if you can figure out what I'm going to draw before I actually finish it. For those of you that have been doing your work this year and during the last few months, I want to tell you it has been pretty good quality work. I'm out.